Alright, welcome to today's lesson on the binary number system. But before we can talk about the binary number system, I want to go back to talk about the decimal system, because that's what you and I as humans have learned to count in. And if we think back to when we first learned to count, we might remember this guy from Sesame Street, and he showed us the various digits that we have working as numbers, so all the digits from 0 up to 9. And when we first learned to count, we probably used our fingers, and for some of us in the class, maybe we still use our fingers a little bit for our counting. And because we kept it easy to keep track of 10 things, because we had 10 fingers, we made a number system based on those 10 things as well. It's called the decimal system, or the base 10 system, because it is based on the number 10, or every number that we could possibly make is a combination of 10 different digits. Right? 0 through 9. So any number we make has some combination of those digits in whatever order. So number 957 would be the digit 957. So all numbers that we can create are combinations of these symbols. Now the binary system works the same way, except if you think about a computer, it doesn't have 10 digits. Instead, it only has 2. Why 2? Well, because computers process, store, and transmit information as electrical impulses. So the impulses are either on or off. So therefore, if you think about it this way, a computer has 2 fingers, right? On and off. So it's easily counting in a base 2 system, right? We have off with a value of 0, and on has a value of 1. So that means that at the machine level, computers use a combination of 2 digits to represent any information that could possibly be stored on it. 0 and 1. That's it. So all the pictures you put on there, videos, video games, everything ultimately is broken down into zeros and ones, which is kind of crazy if you think about it. So this 2-digit system is called the binary number system, or base 2, because it's based on 2 digits, as opposed to our base 10 system based on 10 digits. So now we know what the binary system is as compared to the decimal system. We want to start figuring out how we can convert between binary and decimal. So we can figure out when I type a number in a computer, how it can be computed and understood by the computer. So to do this, we have to look at how each system combines digits or symbols to form larger numbers. So let's look at the decimal system and the number 987. If you break this down like you did when you were back in grade 1 or grade 2, we know that we had various columns. So we had the ones column, the tens column, the hundreds column, and so on. So in this case, I have 7 in the ones column, 8 in the tens column, and 9 in the hundreds column. Another way of writing that is saying it's 10 to the power of 0. That's a 1. 10 to the power of 1 is 10. 10 squared is 100. 10 cubed would be 1,000, and so on and so forth. Each column, as I move from right to left, is multiplied by 10 as its value. Okay? So I can now calculate my number by adding those powers of 10. So again, remember, 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 squared is 100, and so on. So if I want to figure out what the number of 987 actually is, I would say, well, I have 7 in the ones column, and I add that to 8 in the tens column, adding that to 9 in the hundreds column, looking like this. Add them all up, I get 900 plus 80 plus 7, or 987. So really in this case I'm kind of converting the decimal number to the decimal number. Okay? Think again, another way of looking at it is if I had $987 in cash, I might have 7 loonies, 8 $10 bills, and 9 $100 bills. Again, I've got the place values. Each column has its value. Okay, another example. This time we've gone one column further. So now I've got the ones, the tens, the hundreds, and now I've got 10 to the power of 3, or the 1000s column. So I break that down, and I end up with the number 2075. So we do the same thing when we're working in binary system. We also have place values. But again, remember, we can't work with the numbers of 10. We have to work with the numbers of 2. So let's look at the binary number 1011. What is this number going to equal in a decimal number? What is that the equivalent of? Well, again, we're going to work in columns of 2. So this is the ones column, or 2 to the power of 0. Our next column is the 2's column, or 2 to the power of 1. Then I'll be at 2 to the power of 2, 2 to the power of 3, or the 8ths column. Just like we did before, we can add those powers up to figure out our value in decimal. So 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, and so on. So 1011 would be 1 times 2 to the power of 0, 1 times 2, plus 0 times 4, plus 1 times 8, or 8 plus 0 plus 2 plus 1. That value is 11. So this number, 1011, in binary is equal to the number 11 in decimal. I can also write the number as 0001011. Just like in the decimal system, any leading zeros out in front of the number are ignored. So still, that number would be looking like 1011. So if I see the number 1011, what does it mean? Am I talking about the number 11? Or am I talking about the number 1011? Which one am I talking about? Well, to avoid confusing this as a binary versus a decimal number, we usually use a little subscript 2 to indicate that it's a base 2 number. So it looks like this. So now I know that this is talking about the decimal number 11 instead of the decimal number 1011. Well, that's all a little bit complex. Isn't there kind of an easier way to do this? Well, the answer is yes. The decimal equivalent of a binary number is basically the sum of all the place values which are filled by a 1. Half of you right now are going, what is he talking about? Well, let's take a look at an example. I want to convert this number into its decimal equivalent. The easy way to do that is to draw a box with 8 squares for each digit in the binary number. So there's my 8 squares. I'm going to fill the boxes from right to left, and if I run out of numbers, I'm going to fill the extra ones with zeros. So 0, 1, 1, 1, 0, 1. That's the whole number, so I have extra spaces, I'm going to fill those with zeros. Once you've done that, you're going to draw another box under the first one and fill in the place values for each digit. So again, we know this is the 1's column, the 2's column, the 4's column, 8, 16, 32, 64, 128, and I could keep going. I could go 256, 512, and so on, okay, if I wanted to do so. Now all I need to do is everything that has a 1 above it, I want to add those ones together. So this number would be 32 plus 8 plus 4 plus 2. That gives me the number 46. So 101110 is equal to the number 46 in the decimal system. Take a minute, pause the video, and try and calculate the decimal values of each of these binary numbers. When you're finished, press play and check your answers. So here are the answers. Okay, there's the 5 questions with the 5 answers. If you have any questions, you can try and work through them again, or bring your questions to class tomorrow and we'll take them up. Before we go though, we need to convert in the other direction, from decimal to binary. So to do this, it requires simple division skills. So hopefully we all know how to divide by 2, because in a test, you're going to have to be able to do this without using a calculator. Okay? So dividing the number by 2, you need to record the whole number result and the remainder. You take that answer from step 1 and divide it by 2, recording its whole number and remainder. You keep doing this until your final result is a 0. And once you've got that 0, you read the number from bottom to top to get your final answer. So let's take a look here. Convert the number 26 to binary. Well, 26 divided by 2 is 13, and it divides evenly. There's nothing left over. It's an even number. So I take that answer, divide it by 2. 13 divided by 2 goes 6 times, and I have 1 left over. Because it's an odd number, I can't divide evenly, so I have 1 left over. 6 divided by 2 is 3, with nothing left over. Take that answer, divide it by 2. 3 divided by 2 goes 1 time, with 1 left over. And 1 divided by 2 is 0, with 1 remainder. So now I've finally gotten my answer 0. If I go backwards here, I can go 1, 1, 1, 1, 0, 1, 0. That is my answer in binary. So 26 in decimal is equal to 11010. If you're not sure, convert it back the other direction and double check to make sure that this gives me the value of 26. So again, I want you to try converting these decimal numbers into binary. Pause the video, and when you think you have the correct answers, press play and see what you get. So here are the answers for the 7 questions that we saw before. If you have any questions about this, you can go back, try again, rewatch the lesson, or come to class tomorrow where we will work on what we've learned in the lesson today.